we're going to do the notes for 10.2, talking about arc measures. All right, so some definitions to start with. We got a central arc. So central arc is an angle created using the center of a circle as its vertex. So we have 3 central angles here. Angle 1, angle 2, angle 3. So the angle is created using the center as the vertex of the angle. The sum of all of your central angles is always 360 degrees. Okay, so the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is always going to be 360 degrees. And even if you had like an angle 4 and an angle 5 and an angle 6, adds up to 360. Arc measure. So the arc measure that's created by your central angle is congruent to the angle. Okay, so this arc here, its arc measure is congruent to this angle measure, okay? And that is specific to central angles. A minor arc has an arc measure of 180 or less than 180 degrees. So this arc here would be a minor arc because angle PQR is less than 180. So the arc measure is less than 180. A major arc has a arc measure greater than 180. So the angle that you're looking at is greater than 180. Usually with a major arc, we use 3 points to label the arc. Okay, so here we're talking about arc PTR. Okay, we add that T in there that tells us to go this way around the circle instead of the other way. This would be a major arc because this angle here is definitely greater than 180. It is greater than a straight line. Then a semicircle is an arc with a measure that's equal to 180. So the central angle is a diameter and then a semicircle around. All right. Find the value of x. Okay, well, the sum of all the central angles is 360. So if I do 360 minus 145 minus 165, I get 50. So x is 50 degrees. So pause here, try this one on your own. Okay, find the value of x. You know this is 90. Oops, this is 90. So we'll do 180 minus 90 minus 40 minus 85. And you'll get, or not 180, start with 360. And you'll get 145 degrees for that angle x. Use this circle for the following 3 problems. So name 2 minor arcs and find their measures. So one minor arc I see is one that we're given, arc GH. So arc GH is a minor arc because its arc measure is 122 degrees, which is less than 180. And I also see arc HJ. And that would have 180 minus 122. That would have a 58 degree arc measure because the central angle is 58 degrees. Now, let's do 2 major arcs. So one major arc that I see would be arc GLH. Okay, so arc GLH goes all the way around. GLJ is 180, and then 180 plus the 58 would be 238 degrees. And then I also see arc JGH. So if I go around this way, JGH in the red, that would be a major arc. That'd be JLG is 180 plus 122, or you can do 360 minus 58. You get 302 degrees. And then 2 semicircles that we have here. So I see, we could name a few. You could just say J or GJ, JG, and that would take us both ways around. We could say GHJ, we could say GLJ, okay, but they all add to, or they all are 180 degrees because that is what a semicircle is. All right, for this next part, tell whether the given arcs are congruent for the three following sets of circles. Okay, so arcs are congruent if they have the same measure, so central angle, and if they have the same length. So when you're thinking of arc length, think of you're standing at this point and you walk the arc. That distance there, arc distance is arc length. Okay, so as long as those are both the same, then you have congruent arcs. So here in this circle, we're using the same circle, so that helps here. These two arcs, CD and EF, have the same measure, right? They are both 80 degrees. And they also have the same length. And we know they have the same length because they cut this circle into the same fraction, right? The same sized part because they're both 80 degrees out of 360 degrees. So these arcs are congruent. Now if we come here, we have two circles that we're looking at. We have this circle here and this circle here. These two circles both have the same central angle of 90, so they have the same arc measure. But if you look at walking from T to U, that's definitely longer than walking from R to S. So they don't have the same length. So we would say that these are definitely not congruent arcs. And then for this last one here, okay, we're looking at two different circles now. We can think of these as the same circle though because they're congruent circles. They have the same radius. Now if we look at these arc measures, they have the same measure of 95 degrees, but then they also will have the same length because since the arc or the circles are congruent, that means a 95 degree angle in one circle will create the same sized arc as in another circle. So we could say that these arcs are congruent. All right, moving on. PM is the diameter of circle R. Identify each arc as major, minor, or semicircle, then find its measure. All right, first thing I'm going to do is I'm going to label this circle up and find these measures. So if PM is a diameter, that means this angle is a linear pair with this angle, so this is also a 90 degree. And that means this angle is a linear pair with this angle, so this would be 180 minus 115, which is 65 degrees. So let's go through and find these arc measures. So MQ is this arc here, which is a 65 degree arc measure, so it is a minor arc. Arc MNP, well PM we're told it's the diameter, so that's 180 degrees, which would make it a semicircle. And then arc MNQ goes all the way around to here. So if I do 180 plus 115, I get an arc measure of 295. So 295 degrees, definitely greater than 180. So this would be a major arc. All right, so I want you to pause here and do this next one on your own. All right, so hopefully you went through and just kind of filled this in as much as you could. So that would be 90 degree. These are vertical angles, so this would be 63 degrees. 90 plus 63 plus this angle, this little unknown slice should be 180. So 180 minus 90 minus 63 would make this 27 degrees. And then, since this is a straight line, 180 minus 63 would give me a angle measure of 117 there. So arc AED is a minor arc of 153 degrees. ADB is a major arc, 243, and CE is a minor arc of 117. All right, use the following pie chart to find the measures of the following arcs. So arc CD, so that'd be this arc here. We're not told the measure of the central angle, but this is 18%, okay? So percents are out of 100, so 100% of this circle would be 360 degrees, okay? So we're going to make a proportion here. 100% of the circle, so the whole of the circle, in degrees, that'd be 360. We know the percentage for this arc is 18. Let's find the degrees for this arc. So like on the top here, I am doing this arc specifically, and this bottom part is for the whole circle. Alright, so I solve this proportion by cross multiplying. I get 100x equals 6,480. So x equals 64.8 degrees. So that would be the arc measure for the arc CD, because that would be this angle measure. Alright, arc BC. Now notice BC is also 18 degrees, so guess what? Same exact arc measure. And then this last one, arc BDF. So B to D to F. If I add all of those percents together, I get 18 plus 18. You know what? I could just write it out, right? 18 plus 18 plus 16 plus 14 out of 100 equals x out of 360. If I add these together, I get 66. So now I cross multiply and get 100x equals 66 times 360 is 23,760. Divide by 100, x equals 237.6 degrees. So that means this angle here, measure on this way, has that arc, has that measure, so this arc has that measure. And last one, we're going to actually find arc length. And notice, it's just a proportion like we had above, okay? So your proportion, you are still going to have this arc on the top, so the arc you're looking for, with the whole circle on the bottom, okay? So, whoops. So, the circumference, you're going to do 2 pi r, pi times diameter, or if you're able to find the circumference and put it on the bottom. Keep it in terms of pi, it'll just keep things easier for you. And then the arc length is going to be on the top. And then these, okay, so these have the same units, and these are both distances. Circumference is the distance all the way around. Arc length is just that one arc's distance. And these are both in degrees because arc measure is congruent to the central angle measure. All right, so let's do this example. Find the length of arc ZY, round your answer to the nearest hundredth. So it's arc length, don't know, over circumference. So circumference is pi times the diameter. Diameter is 4 plus 4, which is 8. So 8 pi equals the arc measure, which is just this angle measure, 75 over 360. So we cross multiply and get 360x equals, if I do 75 times 8, I think I get 600. So 600 pi. And then if I divide by 360, I get that x equals about 5.24. So that would be the length of arc ZY. Alright, so I want you to pause here and try that problem, same type of problem, but for this second one. So try it on your own. Alright, so if we look at it, we set it up. The angle, or the arc measure of ZY is 130 because its central angle is 130, and that's out of 360. We're trying to find the arc length, but the out of the circumference, which is 10 pi. So cross multiply, and then divide by 360 to get 11.34 centimeters. Which reminds me, we forgot our units on this last one. It would be inches. All right, one more together. Given the arc length, find the measure of the central angle. So we're trying to find this angle here. So we know the arc length, and that's out of the whole circumference of, well, the radius is 8, so the diameter is 16, so 16 pi. The arc measure is always going to be out of 360 degrees. We're trying to find that specific arc measure. So we're going to cross multiply. I'll get 16 pi x equals 5.3 times 360 is 1,908. And I'm going to divide by 16 pi to get x by itself. You got to be careful here. When you type this in your calculator, you need to make sure to put parentheses around the 16 pi. If you don't, your calculator is going to do 1908 divided by 16 and then multiply it by pi. But we want this divided by the 16 times pi. All right, so I'll get x equals 37.96, and then our units would be degrees because we're finding the central angle here. And that completes the notes for 10.2.